let's look at another way of using node voltage analysis to solve this circuit over here. Okay, so right now, what we're going to do is first we're going to redraw the circuit by removing the load, okay, which is R5 over here. So let's go ahead and do that. So I have a 5 volts source here, and I have R2, okay, and my 10 volts here, another node there, and R4, okay, and then I have R1 up here. Okay, so let me label the nodes a bit clearly here. So this is node 3, this is node 2, this is your node 4, okay, this is my node 1. Okay, and what we are interested in is the VTH as seen by the load. In my other video, I took the N4 as my reference, which is ground, which is 0 volts, alright, and then from there I derived the rest of the voltages and current equations. Now in this video, what I'm going to show you is how we're going to use the 10 volts negative as the ground and use that as the reference point. Alright, so let me go ahead to draw the 10 volts as a super loop over here, a super node over here. And as before, once you have a super node, you can derive the current equations as all the currents going in to the node or going out of the node. Okay, so in this case, I'm going to take it as all the currents going in to the node over here, and let's come up with the equations. So for this branch over here, I can say that that is N3 minus N2 over R2 plus the current going up here will be N4 minus N2 over R4 plus the current in this branch to R1 will be N3 minus N1 over R1 equals to 0. Okay, so now that we have this equation, let's look at the actual voltages that are represented by the different nodes. So we have used N1, okay, in this video here as the reference. So N1 is 0 volts. So N2 is 10 volts, correct? So it is 0 plus the 10 volts applied. So N2 is 10 volts. All right. Now, what about N4? N4 is basically the voltage we want to find, where N4 represents this point over here as well. So by finding N4 with respect to N1, which is ground, we are actually finding VTH. So N4 is the variable that we want to find. All right. And how about N3? So we will label N4 as V1, and N3 will be V1 plus 5. So whatever voltage that N4 is in, N3 will be 5 volts higher than that. All right. So with this understanding, let's now populate the equation. So N3 is V1 plus 5, all right, minus N2, which is 10 over R2 plus N4, which is V1 minus N2, which is 10 over R4 plus N3, V1 plus 5 minus N1, which is 0 over R1 equals to 0. Alright, so let's go ahead to put in the numbers for the resistor. So this is 2 ohm, this is 1 ohm, this is 1 ohm. So what I have here is V1, okay, over 2 negative, so 5 minus 10 negative 5, so negative 5 over 2 plus V1 minus 10 plus V1 plus 5 equals to 0. Alright, so with this, let's simplify here. With this, what we have is 5 over 2 V1. Alright, so this is 5, negative 5 over 2, negative 5 over 2. So I'll have negative 15 over 2 equals to 0. Okay, and 5 over 2 V1 equals to 15 over 2, and V1 equals to 3 volts. Okay, so now you see we get V1 equals to 3 volts, and this 3 volts is with respect to the ground being on top here. Okay, the ground being on top. So the node 1 here is the ground, correct? And N4, which is V1, is 3 volts higher than this point here. So if you were to draw the supply, okay, it will be drawn as ground over here, and you are 3 volts higher with respect to the ground on top. So that is how you will have drawn your supply. So you can see that we get the same answer, all right, whether we take the reference as the ground from the 5 volts, or we take the reference as the ground from the 10 volts. All right, so as long as you apply the correct analysis in terms of voltages and current flow to the super node, the answer would still be the same. Okay, so I hope you can see this video together with the other video that I have released, where the 5 volts ground is used as the reference, and compare both approaches. Okay, you will see that they are both equivalent in the way we have handled the question. It's just that one has taken or each has taken a different ground as the reference point. All right, thank you very much for watching. In my next video, I will talk about the Thevenin resistance for the circuit. All right, thank you. Bye.